are going to discover next how Siemens and AWS are accelerating industrial AI at scale using real-world vision AI deployments in the Siemens electronics plant in Erlangen. And by standardizing this joint Siemens Industrial Edge and AWS architecture, deployment times have been able to drop from months all the way down to days. And here to tell us more, I'm glad to be joined now by our two guests. We have from Siemens, advanced optical inspection and closed-loop manufacturing expert Marvin Herchenbach, and from AWS, we have Principal Partner Development Manager for Industrial, Dr. Henning Rudolph. Gentlemen, thanks for being here. The stage is all yours.
Perfect. Thank you very much, Max, for the warm introduction. We are very happy to be here for this presentation. And before we go into the details of the great things that we've been doing together in the electronics factory in Erlangen, let me tell you a little bit about the origin, the history of our partnership, which originated roughly around 2015. And for those of you who remember 2015, 11 years ago, that was the year where Apple brought out the new Apple Watch. 1 million devices sold within the first 6 hours, and ambiguous computing was everywhere. People got connected. Here at Hannover Fair, it was the beginning of Industry 4.0. The promise of connected devices bringing productivity gains. Siemens, of course, Marvin was already here. AWS was not yet here on the stage. We waited for another 2 years until we released our first product, actually together with Siemens. And what we already started building out there is what you see on this presentation, bringing together AWS and Siemens. Siemens mostly comes with the deep history of hardware in the field. What you see on the slide in the lower left corner is the connectivity, the data integration, and this cannot be over-exaggerated. It's crucial that you as an end customer and also a machine provider have access to the data. And typically it's a lot of brownfield, so you need to have the knowledge over decades how to connect to a variety of machines out in the field. So, but what do you then do with the data? I mean, the data as such is the base, but you need to bring it up to a compute layer. That's why our two companies together innovated in the area of edge computing, Siemens Industrial Edge as the platform, and together we developed then applications that run on top of this platform, feed up data to the cloud. You can think of it similar to an Apple Watch, that you can measure the heartbeat beat at the person, at the machine, and this then goes up to the cloud for analytics and further use cases, feeding data to other sources and also back to the device. So this in a nutshell is what we've been working on. Again, partnership has been running for 11 years. We were here already last year, 2024, showing you the first case of the application of what we've been doing together. And today is the time that we take you to the next level. So last time we talked about the first uses implemented, and now we are all about scaling. Cloud computing is about scale, and together we worked on the concepts how to also scale the use cases in the factory environment. And I'm really happy to be here with Marvin today, as the factory in Erlangen is only 50 minutes drive away from my place. So Marvin, take us through the great use cases you've been implementing.
Yeah, thanks Henning already for the introduction of AWS. So let's start with our factory introduction. So Electronics Factory Erlangen was established around 50 years ago, and it's really already a brownfield factory. So we are now optimizing a lot of different production lines to get all about productivity gains, all the entire chain. So you can see we have here motion control as a business portfolio element. So we produce so-called inverters. This is a cinematics portfolio element, and we also have the numeric, which is the control. All in all, it's the intelligent setup to drive the motor. So we have the intelligence, and we have also here the inverters who do the power electronics So it's all about translation and logic signal to the drive. And by also having so much different product types, we have different product variants to produce. So we have here a mid-volume to high mix production. So it's a lot of different products which can be configured by the customer itself. That means we have also a heterogeneous production. So it's a lot of challenges to optimize, to get it further smooth running. And we implemented also in the last several years over 100 AI models which are running in the shop floor now. And this was also already awarded last year with the World Economic Forum by the Lighthouse Factory. So we are also proud member here. And now we want to show you a few examples of this production, how we improve our production on a daily basis. So here you can see a so-called THT assembly line. THT is a through-hole technology process. So you can see here typical product of us. So we have here different components of different size. It's like solving a puzzle, but just a bigger size, I would say. And the first step is putting all the components in a place. It is here the assembly process. So it can be done by humans or robot, depending here on our vision here. And then we have to check if everything is there. And this is the first use case about. So we have here an AOI. This is an automatic optical inspection to inspect all the quality of our placement. Afterwards, if everything is placed, then we have the soldering process. And for the soldering, we have now here a new vision use case, which is all about checking the quality of so-called fluxing. It's is a transparent fluid, which can now inspect by using a thermal-based camera the quality if everything is here sprayed, everything is more or less glued together. And here we also introduced a new function for our industrial edge. So in the past, there was only normal cameras available, supported. Now we can use also in the next dimension, like thermal-based camera. After gluing everything together and having here the soldering done, for example, we do the so-called AOI again, which is an optical inspection that inspects the quality of the soldering. And here, typically AOIs have so-called static rule-based inspection. And by further optimizing here this, we use now digital tools after having it improved by lean philosophy. We can use digital tools to further reduce your so-called false positives. That means if the AOI says it's a fail, typically the human has to inspect this, if it's a real error or not a real error, so we have a manual touch-up, and now the AI take over this role automatically. We have a reduction in our productivity, or increase in our productivity, reduction in our manual efforts. And finally, we also have a so-called coding process. You can see shiny surfaces here, which is the coding of our process, and we have here as well a low-cost inspection made together with smart algorithmic, which is low cost, but using also cloud for scaling it across the factories and cells. So all in all, you can see 4 different use cases using exactly the same stack, and all is made together with AWS.
Right. And Marvin, what really impressed me a lot is we saw here also what we at AWS call a flywheel. The typical Amazon flywheel is that if you're reducing cost, you're attracting more customers. With more attracted customers, you increase the number of sellers on AWS. And with more sellers, more varieties coming again, you get more customers in. And then the next round of this flywheel is starting. Yeah. I think what we are seeing here in practice is you also putting in, or us together putting in a flywheel. I think the first use case that was the heavy lifting, building in security as job zero initially. So can you talk us a little bit through how long did the first use case take? How long the second? How much could we then spin up this flywheel?
Yeah, so indeed the first use case here, number 1, was all about 5 to 6 months. So we did all the customizing and also all the setting up the architecture once together with AWS, with all the partners here. And then we did or used this blueprint for all the other use cases. So in less 2, 3, 5 days, we have already implemented this on our production cells. And the last use case, which is the coding, was running on day 1 already.
No, really, really impressive.
And also here, if you look what is now the target also for our future, it's a so-called future automatic manufacturing. We have here again the production line, and we have AWS as a cloud system. But we want to also run further algorithms, further optimization. And you can see here, all running typically on AWS. But to get everything connected, we use here our industrial edge ecosystem as a glue, as an intermediate layer between IT and OT. And we have running now the different use cases, but also it enables us in future to work here much closer together, enabling closed loop by using an AI model to control the other one here. Typical approach is agentic AI. I think also AWS is working on this topic as well. Or what is here your vision as well?
Yes, I mean, what we are seeing is more and more the promise of Industry 4.0 now also gets delivered with the use of agentic AI. There's so many routine work you can offload and simply have an AI running in the background doing for you, and you can check results again then with simulation. So I think we will see a lot of improvements the years to come. We're just at the beginning, that's for sure.
Yeah, indeed. Now, let's have a look how we together set up our here solution, which we mentioned here. You can see here the typical build to run cycle, which is the MLOps, the machine learning operation cycle. And it goes hand to hand, so from edge to cloud, together with Siemens and AWS. And we want to show now the entire cycle, how it's working here with our product portfolios. So it's starting all about here the industrial edge on the shop floor level, that means on field level. We have everything connected with our edge. So we collect the data from machines like image data. We collect it from cameras. Here you can use so-called vision connectors from Industrial AI Suite, which is a product portfolio from ourselves. Then we have a lot of different other data sources, and it's all together in our edge ecosystem available. Now here is also the running process of the AI model. That means the AI model consumes all the data, image data, machine data, and can do the prediction itself. So this is the optimization of the process here. And the results are then sent either to a machine to control it, closed loop, or we also send it out to the cloud system. And here also AWS comes into place that we have a closed loop as well for the entire training and deployment.
Yeah. And Marvin, maybe before I jump into what we do on the left side of the circle, let's maybe also contrapose how you worked in the past. My understanding was before leveraging cloud, you had to buy local compute, and it could take you months until you had procured new hardware that you could use for these topics. Is that the case?
Yeah, definitely the case. So in the past, a data scientist collected the data manually on-premise systems, or we also had different so-called pipelines. That means every use case was more or less a silo itself. And it was not scaling across the different cells, across the factories. For this, we needed a repeatable, standardized approach here and came together with our solution here. Yeah.
Awesome. And I think what we now build together is, as you see the swoosh to go to the left side of the picture, the data that's collected on the shop floor with the pictures and the machine data is then fed into the storage on AWS side. It's with Amazon S3. That's our storage that has virtually unlimited storage capacity, and it also brings lifecycle data. That means data that is not used anymore. It gets into very deep archives, very cost efficient, and it only needs to be recalled once or twice a year. But the data that's super fresh, you get it in a way that with latency you can draw it out in a fraction of a moment. That's on the storage side. On the compute side, we use together Lambda functions. This is again a compute-less computing. That means you don't need to run the compute infrastructure yourself. You simply have an endpoint that you can trigger with APIs, and it just works as an infrastructure. And the same is also true for what you see on this picture with EKS. This is our container platform, and you can think of it that compute power as container is only spun up if you need it for your next job. So for example, when the next job comes, you need a graphical compute power, a so-called GPU, but these things are very costly. So instead of having them all the time on premises, you just, as a container, spin them up when you need them, you run the job, and once the job is done, then again, you redeploy it, and you're saving cost as you are using the scalability of the cloud itself. Once this has been processed, then the data gets fed back based on the template approach that we invented together into the packaging. And with the packaging, I think it's back to you, Marvin. It goes back down to the shop floor.
Yeah, but maybe let's have a look first on the template approach. So this is a new one here. So in the past, as mentioned, we have different silos for every AI use case. That means you have expert for this AI model, expert for this AI model. But the future is that, for example, the operator from the factory can itself operate all the AI models by once. That means we have a unified user interface which is doable or operatable for every AI use case. And therefore, we have so-called templates. We can take as analogy, for example, cooking in private life. In the past, everybody had, for example, an oven and fryer and mixer, depending on the food which you want to prepare. And nowadays, everybody has maybe a Thermomix or an air fryer. There's a lot of different recipes and programs. You have a platform here, and you select here then only the recipe to which you want to eat then in the end. And the recipe is here exactly the template. So the data scientist who is creating the AI model is doing it always in the same way. Therefore, we reduce as well the engineering, but the operation is always the same platform. And the domain expert, the operator itself, can do now the operation from every AI model, vision AI model here by themselves. And after getting now the model, which is then also packaged here from this platform, so we have as well here our Siemens-AWS SDK included, ready for industrial edge. We have the deployment also automatically to the edge device itself. So here we have the so-called AI asset manager. It's like a hub system for the different edge devices which are running all around the factory. So it's like a factory-wide control system, and you can deploy the AI models, but you can also monitor them. That means, for example, if one machine is not working well, you can directly see here and drift and can react here, either manually or automatically in future as well. And then we close the loop and have now the possibility to do this again for example, further optimization or for new use cases, because it's scaling here across the entire loop. So it's going hand to hand, and we have a reuse reduction by using this kind of modular pieces in our engineering, but as well in our operation due to the platform here.
Marvin, that means now with all these recipes, you don't need to be a star cook anymore to have something that tastes really well. The layman, so to speak, can do it. You don't need IT experts to run this, correct?
Yeah, that's right. So you only have once here the recipe creation, I would say, but you can now reuse the star-cooked recipe, and you can also enjoy it in every factory, so you can benefit in a factory network as well here. Yeah.
So you're now even sharing the recipe book across the different factories?
Yes, indeed, yeah.
Super impressive.
So now let's have a look on the numbers itself. So as mentioned, we're using here really this template-based approach, which is here the platform, which gives us a lot of engineering potential. So we talk about 60% here, because as mentioned, the data scientists can now focus only on the AI model and use the template-based approach. This is one of the first approaches here, which we now implemented in our Lighthouse factory. Secondly, as mentioned in our title, we can deploy it much faster now, because we have the engineering, we have also the operation goes hand in hand, and we have an automatically deployment mechanism, so it's already in days available on the shop floor if you have the POC already done on this kind of modular approach. And finally, you have then here the service cost, because you have only one solution, one platform, you have only one service. You have not a lot of silos going on here, and you have here a reduction in operation, which is also beneficial for us as a factory.
No, super impressive. And Marvin, can you tell me a little bit your experience? How are you now scaling this from one factory to the other? Are they coming? Do they see the benefits? Do they want to have your recipes, or how do you actually do this in practice?
Yeah, so first, after implementing this on one cell, we want to scale it internally at the factory itself. So we have a lot of parallel production here, so we scale it at a lot of different production machines, but we are also scaling it in our factory. Depending on the other setup of the factory, they are interested maybe in the coding, maybe interested in our solving use cases, like a recipe. Not everybody likes every food here, so it's also like a pull from the other factory. We have here a market, internal market more or less, and everybody can then share only the recipe, because they're following the same platform. It's also here scaling here as well across the factory, because we are following the same language, the same platform idea, and only gives here the recipe to the other ones.
No, that's really impressive, and I also love that you're not scaling just, let's say, in Europe, you're scaling globally, and I think, again, that shows hand in hand our partnership, that we have this in different regions, giving you also the latency for the compute that you need for these advanced use cases. So again, super impressive that Siemens brings the global scale of how you bring this to production. And I think together we are able to serve you with the topics and the services globally, so that you're able to execute this way.
Yeah.